Namaskar, Jai Guru. I am Ritesh Kumar Pathak, Department of Physics, Intermediate Section of Yogoda Satsanga Mahavidyalaya. In this lecture, I will introduce you with Coulomb's law and its vector form, which is one of the topic from the chapter Electrostatics of Class 12. But before going to that, we should know about Mr. Coulomb. Charles Augustin de Coulomb was a French physicist, as you can see in the diagram. Began his career as a military engineer in the West Indies. In 1776, he returned to Paris and retired to a small estate to do his scientific research and invented torsion balance, which was a sensitive device to measure the quantity of a force. He used it for the determination of forces of electric attraction or repulsion between small charged spheres. Here I have taken a small diagram of torsion balance. Here you can see there are two charged pith balls, positive and negative, and along with that positive charge there is another positive charge of the same dimension. There is also a torsion fiber, scale and all equipment. Here one thing is written: the negatively charged ball attracts the positive charged one, and the positive ball moves until the elastic forces in the torsion fiber balance the electrostatic attraction. And it was the apparatus by the help of which Coulomb had given two important statements of his law. Let us understand his thought in very simple way to discover the relation. He supposed the charge on a metallic sphere was the value Q. If the sphere is put in contact with an identical uncharged sphere, the charge will spread over two spheres, and by symmetry we can say that each sphere will have the charge Q upon 2. Now if we repeat this process, means if we take two or more uncharged sphere, the charges will be again distributed and may have the value Q upon 2 or Q upon 4. Also, Coulomb varied the distance for a fixed pair of charges and measured the forces for different situations, or you can say different separations. Then he varied the charges in pairs, but keeping the distance fixed for each pair. And after comparison for different pair of charges at different distances, he found the relation for forces, as we will see in the next slide. Here, for defining the mathematical statement of Coulomb's law, I have assumed two charges Q1 and Q2 which are separated in vacuum by a distance small r, as you can see in the diagram. As they are two charges, there will be a force of attraction or repulsion. Also, I have assumed they are point charges, as we have discussed those charges which have the dimension very less in respect of their distances or separations between them. Then this force of attraction or repulsion between them is, number one, directly proportional to the product of the magnitude of charges. And mathematically, if you want to show that, we may write F proportional the magnitude of charge Q1 into the magnitude of charge Q2. Secondly, the same force of attraction or repulsion between two charges is inversely proportional to the square of the distance between them. And mathematically we may write F proportional 1 upon R square. Combining both the relations, we get the formula F proportional Q1 Q2 upon R square. Further simplifying this, F equals to small k Q1 Q2 upon R square, where k is oftenly called Coulomb's constant and which has the value 1 upon 4 pi epsilon naught, which is given here. And if the value is been calculated for small k, that comes 9 into 10 to the power 9 in SI unit. Also, you know epsilon naught, which is the permittivity of free space, it has the value in SI unit is 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. And with the regard of these values, we may write the final equation for the magnitude of forces between two charges as F equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. And this is the magnitude, or you can say the mathematical statement of Coulomb's law. Here we will discuss Coulomb's law in vector form. As you know, force is a vector quantity, so it is better to write Coulomb's law in the vector notation so that we can get the direction of resultant force acting on any charge. So for that, we have to assume two charges, or here I have taken two positive charges Q1 and Q2 with a small distance small r. Since we are going to derive the vector form, we will have to take the force as vector quantity, and which I have taken F21, which is the force, or you can say repulsive force, acting on the charge plus Q2 due to charge plus Q1 in a direction. In opposite to that, there is F12, which is a force acting on charge Q1 due to the charge Q2 in opposite direction. And there is a position vector R21, which is representing the distance of charge Q2 from charge Q1, as well as it is also showing the direction. This direction is similar to the direction of force. Now these two charges are positive in nature, hence they will repel each other, and you can say there are the forces which are in opposite directions. So for R21 vector, we may write magnitude of R into unit vector of R21. So therefore Coulomb's law in vector form may be written as F21 equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, which is nothing but the magnitude of that force, into the unit vector R21. We implemented this unit vector for showing the vector notation of Coulomb's law. Further, we may write vector F21 equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square into vector R21 upon R. From the vector algebra, we may write any unit vector in terms of the vector divided by the magnitude of vector itself. Now F21 vector equals to 1 by 4 pi epsilon naught Q1 Q2 upon R cube into vector R21. Here we have multiplied R square with the magnitude of vector R, and this will be the equation 1. This equation will represent the force of repulsion on charge Q2 due to charge Q1. Similarly, we may write for the equation of force, which is acting on charge q1 due to charge q2, as F12 vector equals to 1 upon 4 pi epsilon naught q1 q2 upon r cube vector r12, and giving this equation 2. From equations 1 and 2 we may also write the force F21 equals to minus of force F12, and this indicates that Coulomb's law agrees with the Newton's third law, that was, to every action there is equal and opposite reaction. I hope this lecture will open an idea about Coulomb's law in your mind. If still there is any problem, leave your comment in inbox. Thank you. Jai Guru.